Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about LinkedList data structure. I will talk about what is LinkedList data structure, how it works, what is the difference between LinkedList and ArrayList data structure, and what are the different methods that we can perform on LinkedList data structure. So guys, if you are willing to do a deep dive into LinkedList data structure, then this video is for you. So please watch this video till the end. So let's get started. Alright guys, so let's begin this video with the very first question, that is, what is linked list data structure? Well, linked list data structure is the data structure that is used to store and organize data so that we can access and modify efficiently. Now here you may ask that we already have array list data structure that is also used to organize and access data efficiently. Then why is the need of linked list data structure? So well, to answer this question, the actual difference between linked list and array list lies in the implementation of linked list and array list. Unlike array list is a list of arrays, whereas linked list is a list of linked objects. But the question over here is, what was the actual problem that we were facing in array list that led to the creation of an entirely new data structure? So let's talk about the problem. So as you know that elements of the array list is stored in contiguous memory location. That is why when we perform a retrieval or access operation over array list, we can do that operation in theta of 1 constant time, right? Because array lists provide random access. On the other hand, if we try to insert or delete elements in the array list, it simply falls behind. Why? Let me show you. So let's say this is the array list and all the elements are arranged in contiguous memory location. And let's say we want to add one item in the middle of this array list. So to add new item in the middle of the array list, first we have to traverse this array list from first element to this point. And then in order to make a space for a new element, so we have to shift all the elements beyond this element to the right by one position. And this again causes a lot of shifting. So overall, if we want to add any element in the middle of array list, in worst case, it takes big of n time to add any element in the middle of the array list. Similarly, let's say we want to remove this element from the middle of the array list. So what happens? We remove this item from the middle. Now this item becomes empty. So to completely eliminate this empty item, we have to shift all the elements beyond this element to the left by one position. So again, this is going to cause a lot of shiftings. And why is it happening? Because all the elements in array list are stored in contiguous memory location. So in worst case, array list takes big of n time to insert and delete the operation. But this problem is very cleverly solved by linked list. So before we talk about how linked list solve this problem, let's talk about the internal working of linked list, that how linked list actually works. So basically linked list has two variations. One is the singly linked list and the second one is the doubly linked list. So let's first understand how singly linked list actually works. So as I said that linked list is a list of linked objects. But here in linked list, object refers to the node, and this node contains two things. Number one is data and the second one is a reference to the next node. So this is the structure of this singly linked list. So here we have one node and this node contains data, that is 1, and the address of the next node, that is the 2. So this piece of information holds the reference to next node. Now next node, that is 2, again contains two things. One is the data, that is 2, and the second one is the reference to the next node. Okay, and here the next node is again 3. So here this node also contains two things. One is 3 and the other one is null. Why null? Because there is no node next to it. That is why the value of this data is equal to null. Okay. Apart from all of these nodes, we also have two extra nodes that keep tracks of the head node and the tail node. So this is a node that contains only reference to the first node. Okay, that is why we call it head node. And the job of this node is to track the head of the linked list. And there is one more node, and this node also contains no data. It contains only the reference to the last node, and we call this node as a tail node. So whenever we want to track the head or the tail of the linked list, we simply use these two nodes to track the head and tail of the linked list. So this was all about this singly linked list. But do you guys realize there is one problem in singly linked list? Let me tell you that if you want to traverse this linked list from first node to last node, then you can simply do like this. Go to head node and this head node has a reference to the first node. So using this reference, you move to first node, and this node has a reference to second node, so you simply move to second node, and second node has a reference to third node, so you can simply move to third node. Now the question over here is now how to go back to the first node. So there is no link that is going back to the first node. So if you want to access the second node, again you have to start from the head node, then go to first node and then to second node. This is the problem that is solved by another type of linked list, that is doubly linked list. So what happens in doubly linked list? So there is one head node and this node stores the reference of the next node, and next node is 1. Now this time this node contains 3 information. First is the data, that is 1, and another 2 is, one is the address of the previous node and one is the address of the next node. So unlike singly linked list, it contains only 2 things, but in doubly linked list, the node of doubly linked list contains 3 things. One is the data and 2 are the references of the previous node and the next node, so that you can traverse back and forth through this node. Okay. Similarly, there is one more node and the value of this node is 2, and this node again contains 2 reference variable, and this reference variable points to the previous node and this reference variable points to the next node, and same as the last node. But in case of last node, there is a data on the last node and the previous variable stores the reference of the previous node, whereas the next variable contains null because there is no node beyond this node, and this is the last node. So as same as singly linked list, we have 2 nodes apart from all these nodes that keep track of head and tail of the linked list. Okay, doubly linked list. So this head node always keep the address of the first node and the tail node always keep the reference of the last node. Okay. So how the doubly linked list solve the problem of traversing back and forth? So let's say you want to traverse the list from first element to second element. So you go to head node, then you go to first node, and then you go to next node, that is second node. So you reach the final destination. So let's say now again you want to traverse back to the first node. So as the left pointer holds the reference to previous node, you can easily use this reference to access the previous node. So this is how you can traverse back and forth using doubly linked list. So how doubly linked list solve the problem of insertion and deletion? So let's see it. Let's say I want to insert a node over here. So in that case, first we have to traverse from first node to this node, and that we were also doing in ArrayList. So there is not a different thing. So let's create a new node, and the value of this node is 4. Okay. What happens here? We do not have to shift any node to the right or to the left of this node. Okay. We simply have to remove this pointer from here and from here, and then just make this reference pointing to this node now, and like this, and here like this, and here like this. So you can see that we are not required to shift any element to the right or to the left of the linked list, and we can update this reference pointer in constant time. This means theta of 1 time. So this is the advantage we get using doubly linked list. Unlike ArrayList, we do not have to shift any node to the right or to the left of its current position. So in ArrayList, it took big of n in worst case, whereas in doubly linked list, it takes theta of n in worst case. So this is a great advantage over time complexity. Now what happens if you want to access or retrieve any node in the doubly linked list? This is where the doubly linked list falls behind, because in ArrayList, as the elements are stored in contiguous memory location, we can perform this operation in big of 1 or theta of 1 constant time. But here in this case, we can perform retrieval operation in theta of n time, because all the elements are stored in non-contiguous memory location. For example, this is a heap. So let's say one object is stored here, one object is stored here, and one object is stored here, and one object is stored here. So first we have to go to this object. This object is going to have a reference to next object. Then using this object, we go to next object. Then this object stores the reference to this object. So using this object, we go to this object. So that is why to access the third element of the linked list, we have to start all the way from head node, then go to first node, then go to third node, and so on and so forth. So as you can see that both the data structure has some pros and cons. In ArrayList, we can access and retrieve any item in constant time, whereas in doubly linked list, it is entirely false. But in case of insertion and deletion, we do insertion and deletion in doubly linked list in theta of n worst case time, whereas in ArrayList, it takes big of n time in worst case. So both the data structure has its pros and cons, and we have to make the trade-off between using ArrayList and linked list. So now the question over here is, which data structure is implemented in a collection framework? So well, in a collection framework, linked list is an implementation of doubly linked list. Okay, so whenever we call a linked list or create a new object of linked list, we always get instance of doubly linked list. So I hope this is clear to you. Now the question over here is when to use which data structure, and this is a genuine question, that which data structure to use. So the usage of these two data structure entirely depend upon the frequency of the operations you are performing. So it totally depends upon the what is the frequent operation. So for example, let's say your frequent operation is retrieval operation. Okay, in that case it's a best thing to use array list because it gives you a random access feature. On the other hand, if you have more frequently retrieval operation, then it is not a good idea to use the linked list because it takes big of n time to access any element. Similarly, if you have insert and delete operations that are very frequent, then you can use linked list because it takes theta of n in worst case to insert and delete an item in the linked list. On the other hand, if the frequent operation is insert and delete, then this is not a good idea to use the array list because array list takes big of n in the worst case. So now I hope this is clear to you that when to use which data structure. If you have more frequent retrieval operation, then use array list, and if you have more frequent insert and delete operation, then use linked list. Now if all of these is clear to you, then we can move ahead to see some of the properties of linked list. So just like array list we are allowed to add duplicates, in linked list also we are totally allowed to add duplicates. Okay, and similarly we are allowed to insert null in array list, so we can also allowed to insert null in linked list also. Now what about heterogeneous objects? Yes, it is allowed in linked list also. So this means we can insert heterogeneous objects in linked list. Now next thing is, in linked list our objects are not stored in contiguous memory location. So due to these we do not get random access, and linked list is not cache friendly as array list because all the objects are stored in non-contiguous memory location. So these are few of the properties of linked list that you should remember, that duplicates are allowed in linked list, null insertion is also allowed, heterogeneous objects are also allowed, and linked list objects are stored in non-contiguous memory location. Now if you look at the collection framework diagram here, you will see that linked list implements list interface, and linked list also implements deck and queue interface. So this means linked list has all the methods that are available in list interface. Okay, and linked list also has all the methods that are available in deck as well as queue. Why? Because deck interface implements queue interface and queue implements collection interface. So linked list has all the methods that are present in list interface, queue interface as well as deck interface. So here are some of the most common methods that are present in array list and linked list. So the first method is add method, and this method is used to add elements at the end of linked list. And as we are adding element at the end, it takes big of one time, constant operation, to insert element at the end. The next method is add method, and this method takes index as argument and object as argument. So it's going to add new element at a specific position. So this operation takes big of index time to add elements at a specific position. Now the next method is remove method. It takes object as argument and it's going to remove this object from the linked list. It takes big of n time to traverse all the elements to find that object and then remove it object, and removal only takes constant time because we just have to change the references. Now next variation of remove method is with the index argument. So this is going to remove the object present at this index. So again it's going to take big of I, that is index time, to remove this element from that index. Now the next method is get method. Get method takes index as argument and returns the element present at this index. It again takes big of I time to get the element. Next is set. Set method is used to set element at a specific position. So it takes index and object as argument and takes big of I time to set element at a specific position. Now the next method is index of, and it takes object as argument. So it returns the index of that object and it's going to take big of n time to get the index of a specific object. Now the next method is empty and size method. These two methods takes big of one constant time to find if the linked list is empty or not and what is the size of linked list. So for your kind information, size returns the number of elements that are contained in the linked list. So these are all the common operations that are present in array list as well as linked list. Now let's talk about the few of the methods that are specific to queue interface. Okay, why queue interface? Because if you look at this diagram, linked list implements deck interface and deck implements queue interface. So this means linked list also implements queue interface indirectly via deck interface. Okay, now queue interface defines functions that are specific to queue data structure. And what is queue data structure? Queue is a data structure that follows FIFO policy. And what is meant by FIFO? FIFO stands for first in, first out. So the elements that are added first will be removed first. So there is one point from where elements are added to the queue, and there is one point from where elements are removed from the queue. And these are the methods that are specific to queue data structure. So the first one is add method. Add method is used to add elements to the end of the queue. Now the next is remove method. Remove method is used to remove the elements from the front of the queue because it follows first in, first out policy. And the next method is element method. So the element method is used to see the element that is present in the front of the queue. Now next thing is there are three more methods that are equivalent to these three methods. Okay. For example, offer. So offer method is used to add element to the end of the queue. Poll is a method that is used to remove element from the front of the queue. Okay. And the peek method is used to see the element present at the front of the queue. So the question over here is, what is the difference between these three methods and these three methods? So well, the difference between these two group of methods are these methods throws exception when calling these methods on a queue when it is in illegal state. So for example, let's say there is a queue and there are only 5 elements allowed in the queue, and the queue is already full and queue is having all the 5 elements. And if you call add method over that queue, then it's going to throw illegal state exception. And let's say the queue is empty, and on empty queue you are calling remove method. So in that case, this method throws no such element exception. If the queue is removed and you are calling element method on the empty queue, it's going to throw no such element exception. So these are the three methods that always, throw exception when you call these methods on a queue that is in a illegal state. But on the other hand, these methods are developer friendly method. So let's say the queue is full and you are calling offer method. Instead of throwing an error, it simply returns false. That means the queue is full and you cannot add new element to it. In case of poll, if the queue is empty and you are calling poll over that queue, instead of throwing error, no such element exception, it simply gives null as a return value. And this null indicates that the queue is empty. Similarly, if you call peek, if the queue is empty, then this also returns null as return value. And all of these operation takes big of one time. Why? Because either we are adding items to the end or we are removing items from the beginning. And as all the elements are not stored in a contiguous memory location, they have only addresses of each other, then we can perform these operations very easily in big of one time complexity. So these are the methods that are specific to queue interface, and a specific method if you want to use a linked list as a queue. Okay, now let's move on to the next section where we are going to talk about the D queue. So if you look at the collection hierarchy diagram, you will see that linked list implements DEC interface, and DEC interface has many methods that are specific to DEC data structure. So for your kind information, DEC stands for the doubly ended queue. Okay, and DEC is the short form of doubly ended queue. Now what happens in doubly ended queue? We have a queue similar to previous queue. The only difference in DEC and queue is in DEC we can add and remove items from the front, and we can also add and remove items at the back. And DEC data structure follows LIFO policy as well as FIFO policy. So in FIFO policy, it acts as a queue, so we can add elements at the end and we can remove elements from the front. And in case of LIFO policy, it acts as a stack. So how a stack works? So this is a classic example of this stack, that is a stack of plates. So what happens? We add plates on top of each other, and when we want to remove any plate, we simply remove the topmost plate from the stack of plates. So that is why we call it last in, first out. So guys, do you know the real beauty of DEC data structure? So DEC data structure is used as a queue as well as a stack. So you can use FIFO policy as well as LIFO policy. Okay. Now this data structure or this interface has few methods that are specific to DEC data structure. For example, add first and add last. Add first element is used to add element to the front of the queue, and the add last method is used to add elements at the last of the queue. Remove first method is used to remove elements from the beginning of the queue, and remove last method is used to remove elements at the back of the queue. Get first method is used to get the element from the front of the queue, and get last method is used to get the element at the back of the queue. And all these methods are also not developer friendly. So when we call add first and add last method on a queue that is already full, it throws illegal state exception. And if we call remove first and remove last element if the queue is empty, then it throws no such element exception. And similarly, if we are going to call get first and get last method on a empty queue, it's going to throw no such element exception. So similarly, queue interface, deck interface also has developer friendly method that are offer first, offer last. So offer first and offer last method is used to add element in the front or in the back of the queue. And in case of queue is full, it simply return false instead of throwing illegal state exception. The next method is poll first and poll last. These two methods are used to remove elements from the first position or from the last position. And this method, if called on empty queue, it simply returns null instead of throwing no such element exception. And similarly, peek first and peek last method is used to see the element at the first position of the queue or at the last position of the queue. And while calling this method on empty queue, it simply returns null instead of throwing no such element exception. So guys, I hope that so far everything is clear to you. So guys, to recall everything once again, let's have a quick recap of this video. So in the beginning, we understood that what is linked list. Then we saw what is the difference between linked list and array list, as the difference lies in the implementation. Array list is a list of arrays, whereas linked list is a list of linked objects. Then we saw what was the actual problem that we faced in array list and how this problem can be solved by linked list and doubly linked list smartly. Then we saw when to use which data structure in which case. So when we have frequent retrieval operation, it's better to use array list. If not, then you can use linked list. And if you have frequent insert and delete operation, in that case you can happily use linked list. Then we saw few of the properties of linked list. Then we saw some of the most common methods that are available in linked list as well as array list. Then we saw the methods that are specific to queue data structure. And then we saw methods that are specific to deck data structure. And we also saw that deck is a data structure that provides implementation as a queue and implementation as a stack. It follows both the policy that is first in first out and last in first out. So guys, if you have learned something valuable from this video, then hit the like button in order to make YouTube happy. Subscribe to the channel and don't forget to click the bell icon so my friend you never miss any upcoming video. So this is all from my side. Thanks for watching. See you in the next video.